I'm John Wilker, the organizer of 360 IDEP. I hope you enjoy this session recording, but first I wanted to mention one thing. We've served the community since 2009, and over the past few years we've had to take on debt in an effort to keep the conference alive. After several unforeseen challenges, not the least of which is a pandemic of indefinite duration, we've had to make the hard choice to end the conference as we're now facing over $100,000 in debt. As a result of requests from the community of how they can help, we've created a GoFundMe campaign. If you're inclined and able, please consider donating to help keep 360 IDEP going. The QR code after this will link you to the campaign. Thank you. Enjoy the recording.
All right. So yeah, it's early and I hope the caffeine has kicked in so that we can get fired up and learn some Firestore. So I'll introduce myself so that I'm no stranger here. My name is Navati and I work as an iOS developer at Loblaw Digital in Toronto. And Loblaw Companies is a major retail grocery chain in Canada. So should you visit Canada, do visit some of our stores. So we are the digital arm of this enterprise, and we work on the digital experiences for online grocery, for beauty, pharmacy, and so much more. And also, I really like being involved in the community. So with women who code in the mobile track as their incoming leadership fellow. And also I'm one of the co-organizers of NS Coder Toronto, which you may know for their Swift UI Jam that happens almost every year now. And also I'm a part of Women Tech Makers. And I enjoy being in these communities because of course, it's great for like community support and learning technical things, but also I find that I get a lot of opportunities to work on things like advocating for diversity and mental health, and I think that really aligns a lot with me. So if that's something you folks want to talk to me about later, please reach out to me. And yeah, if I'm not doing any of these things, then I'm binge watching a lot of TV shows. So as you can see, this person is really enjoying her cake, and that's how I feel about Firestore. I think with Firestore, I can have my cake and eat it too. And I hope I'll convince you folks about why I think this way. So here's the plan. We are going to start with an So we're going to start with an introduction on Firebase, and we'll quickly compare relational database to NoSQL. And then we'll get into the meat of the presentation, which is Firestore, right? So how many of you use Firebase in some capacity? Just as I suspected, a lot of you do. So I'll make this as quick as possible. So I'm sure you agree that Firebase is an amazing toolkit, especially when many of us are more on the front-end side of development. I think Firebase can really help supplement your app development journey because they can help you with your backend services and even things that are related to maintaining your app. So stuff that you may not have expertise in. And the best part is that Firebase is backed by the power of Google Cloud. So if you're like me and you find that this cloud is an opaque box of magical functionality, you'll find Firebase even more impressive. So you don't need to know about the secretive inner workings of the cloud, and yet you can leverage its power. And I'm sure the console page looks familiar to you. And it's this nice, friendly, colorful web page, which is another reason to use Firebase because it's not that intimidating with respect to the cloud. And you can see on the left panel, there are a ton of services. There are services that help with building your app, like authentication, database, hosting, storage, and so much more. There's also release and monitoring, and I'm guessing a lot of you have used Crashlytics. And also there are services for other analytics, engagement, and so on. So that was my quick introduction on Firebase. Now let's quickly compare the two types of database. So I'm guessing many of you know what a relational database is. That was the only database that I learned back in school. And a relational database, as you know, it's implemented as tables. So there are rows and columns, much like a budgeting spreadsheet that can get really hard to balance. The important thing with a relational database is that there is a schema. So what that means is that it describes how your database is organized, like which columns are we going to have, and which of them would serve as the primary key or the primary keys. And it's a relational database, so there are going to be relationships between the different tables. So let's look at an example. Like I warned you that I'm really into watching a lot of TV series. So this is just a small list of some of my favorite TV shows. It's by no means a complete list because I would never be able to fit that in one slide. And you can see that I can use a series ID as the primary key so that I can uniquely identify each of these rows. Also, I can have some constraints or restrictions, such as the title should always be a string, it should be of a certain length, it should not be null because how could you have a TV show with no name? And also the number of seasons should always be an integer. So in that way, we have a schema established. Now, I could have another table for the episodes of these TV shows. And in here, I can use the episode ID as the primary key. So to create a relationship between these two tables, I would use the series ID as the foreign key, which is basically like a borrowed column from the other table. And this is what would help me map the two tables. So for instance, you can see this row is linked to the other row, friends, in the TV series because they have the same series ID. And it's the same case for this row as well. And so we have a relationship created. And similarly, you could link the other rows as well. And a relational database uses the SQL language, which is really great for queries. Now, a challenge with a relational database is that it can get really hard to scale because you have all these relationships to maintain and all these constraints to manage. So that can require a lot of processing power. And so you would need to scale vertically, which means that you're trying to invest in the processing power of your host machine. With NoSQL, they don't have this rigorous schema-based approach. So the focus is on scaling. You can scale fairly easily because you distribute your database across various machines. And the focus is also on speeding up queries. And also you can easily add new fields, which is not that easy with a relational database. So how would you implement a NoSQL DB? One way is you could use the key value-based approach, which is what is used in the Redis database. There's also the wide column-based approach, where not all rows need to have the same columns. And Cassandra is one such example. There's also the graph-based DB, where the entities are nodes with static relationships, and that's what is used in Neo4j. And finally is the document-based DB, which is a JSON-like document, and that's what our Firestore uses. So that was my introduction. I'll now get into the meat of the presentation, Firestore. And we'll discuss some fundamentals. And let's hope to have some fun with these fundamentals and build a foundation so it's easier to understand how to build a DB. So like I mentioned, the Firebase structure is based on documents. You have documents that are very JSON-like. So there are keys and values like in these scenarios. And you can also have a nested value if you need. And in Firestore, we call these nested values as maps. Now, if there's anything that I really want you to take from this presentation is that Firestore is a collection of documents. So what that means is you could think of it as a folder with many different documents. So keep this visual in mind. So I can have a collection, which is very analogous to having a folder. And inside this folder, I can place lots of documents, which is great because you don't want to lose your documents. You want to file them properly. Now, why do we care about these documents? Because they have data, right? So this is the Firestore structure. So let's look at an example. It is back to school season, so let's consider the scenario where you are a school administrator. So I have a student called Kelly and another student called Raj. And I have some documents on each of these students where I can place some basic information like their name, their address, and their major. And like I said, in Firestore, you have to place these documents in a collection. So that's what I'm going to do. And also, I'm going to use this color scheme throughout the presentation. I'm going to use pink for documents, yellow for collections. So yeah, just look out for that. So now I have my database kind of set up. But they're students, so they're probably enrolled in courses. So Kelly could be enrolled in that dreaded algorithms course, and maybe she's taking a course on C++. So I can have documents for these different courses and track information like the course ID, the professor who's teaching the course, and so on. Again, I cannot place these documents loose like this. I have to keep it in a collection. And now you can see that Kelly's document has its own data, but it also has a reference to this sub-collection. So I could do the same thing for Raj, and now I have a hierarchical structure being built. I can take this one step further and maybe track the different assignments that Kelly has been handing in for the algorithms course, and so on for the other courses. So for different courses, maybe we have different kind of submissions, so I could have different kind of data stored, and that's the flexibility that you get with Firestore. So hopefully you're getting an idea of what the data structure looks like in Firestore. So if I were to shrink this database, it would look something like this. As you can see, there is an alternating pattern between collections and documents. So a collection would have documents, and documents, of course, have their own data, but they can also have a reference to another collection, and so on. So it is always this alternating pattern. You cannot have a collection reference another collection, or a document reference another document. And also keep in mind, you always begin with a collection of documents, right? Now, even though you begin with one collection, it's not that there's only one collection that's allowed at the root. You could have more collections. So let's consider the faculty members in here. I could have a collection for them as well, right? And so now I have multiple collections at the base. And with documents, they could reference another sub-collection, and they could even have multiple sub-collections. So my faculty members could be, I could have information about their courses, maybe information about their employee records and the research that they do. So now you can see that Firestore can get pretty flexible. Now, when it comes to the documents in Firestore, when you retrieve it, you cannot retrieve partial documents. You have to fetch the entire document data. And also, there are some limits when it comes to documents. The size of a document is less than an MB, less than or equal to, and the number of fields is equal to 20,000 at max. And when it comes to queries, queries are shallow, and it has nothing to do with the song. But what happens is when you're running a query in Firestore, you're typically running the query against a collection. And let's say I'm trying to find out the grade A students that I have in this database. So my grade A students are obviously Kelly and Raj. They're super brilliant. And I'm going to expect to get their data. And that's what I will get. But I won't get any of the information that is in the sub-collections. So all I'm going to get is these documents. So that's what I mean when I say queries are shallow. And one last concept before we move on is that Firestore has security rules, which is great for access control. So if Raj is being very snoopy and he's trying to figure out how Kelly is doing, you can prevent that with security rules. Also, you can use security rules for validation. So if you want to maintain that a grade is a number between 0 to 100, you can enforce that with security rules as well, which is great because you cannot let a student get 200% even if they're really awesome. So this is beyond the scope of today's talk, but I did want to mention it because it's important. So let's just review these fundamentals. So a file database structure is a collection of documents, and this is the key takeaway for this talk. And also these documents are JSON-like, and you cannot retrieve them partially. Queries are shallow, and you can use security rules for access control as well as for validation. So now we'll get into the last part, and that is building a Firestore database together. So let's apply all of this knowledge, and tell me if you relate to this. You know how we supplement our learning by coming for meetups, workshops, and even conferences, right? And also, we like learning by doing. So sometimes we work on side projects or freelancing, open source, and all of that. Plus, you learn by consuming material from books and courses and blogs, podcasts, and so on. Plus, I'm sure everyone here is networking and making connections and friends. So this is great for a good technical career. But I find it really overwhelming, and I end up looking stressed like this. So I thought, you know what, maybe I should track all these activities. And the best way to do it, of course, would be to create an app, because that's how we solve our problems. We just create yet another app to, create solutions. So let's build a Firestore database for such an app where we can track our various activities. And as you remember, you need to first start with at least one base collection. So our base collection could be a collection of these different activities. I could have a document on a Swift UI session, maybe another on a blockchain workshop, on an online course, and maybe I read a book on design patterns because I wanted to get into debating, right? So now if this is my activities collection, let's look at one of the documents here. Let's say the Swift UI session. Now we'll place some basic fields in this activity document. So let's say the name of the activity is the talk that Wu is giving tomorrow, and the type of the activity is conference, because it could also be a book, a course, so you might want to specify that. And of course, in this case, the organizer is 360 iDev. And if you were to read a book, you could write the author information. If you were doing a course, you could write the instructor information in here. And this is going to be an excellent talk, so the rating is 9. So this is how you can place some basic fields in your document. Now, when you run a query, you have to run the query against a collection. So considering that your collection looks like this, and let's say you want to find out how many of my activities were conferences, this is what it would look like in code. So I would first create a reference to Firestore, and then a reference to the activities collection. And once I'm in this collection, I can run my query with a where clause, like I can say where field activity type is equal to conference. And this is how I would construct a simple query. Now let's say I want to find out how many activities did I enjoy or find useful, and if my enjoyment threshold begins at, say, 7, I could run the query, rating is greater than 7. So you can even have such range operators. Now, tell me, what kind of skills are you guys learning in this conference? These are some of the skills you probably are working on, or you've learned or refreshed, and maybe you want to also track that. So how about we add this to our document as an array? So in this particular conference talk, I could be learning some Swift UI, maybe I'm refreshing UIKit, and of course, iOS. So I can track these skills much like I would do different keywords or tags. And if I want to run a query and find out which of my activities had something to do with Swift UI or UIKit, I can run the array contains any query. Now let's take a little break from this and have a sneak peek at what the Firestore console would look like. So this is what the console would look like in Firebase, and you know that there are these different services in here. But currently, I'm at the Firestore database, and in here you can see that there are different tabs. There is the rules tab where you have your security rules. You can also have this index tab where you can maintain your indexes, and I will talk about that shortly. Also, you can look at the usage of your app. But coming back to the data, so far we have the activities collection at the base, right? And in here we have various documents. So for instance, in this document, I can see that I have this JSON-like data. I could click another document and again view the data. And as you can see, I don't need to always have the same fields. That depends on me. Now let's look at this particular document. I have some data in here, but I also have a sub-collection. So if I click on this sub-collection, I can see the various documents in here. And if I click on one of these documents, I can again retrieve some data. So this is how you can, glance at your data. You can, if you want, even add some new documents or collections, but typically you would be doing that through code. So yeah, that was our little sneak peek there. Now, when it comes to running these queries, like we learn how to construct them, but how would you execute these queries and actually retrieve those matching documents? There are two ways to do so. One is using the single fetch approach, and the other is using a listener-based approach. So with single fetch, you would create, the same reference to your collection, you would apply your where clause, and then you can chain the get documents method, which would give you access to the snapshot of your database at that point of time. And from that snapshot, you can retrieve the documents and treat it like a dictionary and do what you need to do with it. So with the listener-based approach, this callback is going to be executed every time there is a change to your database. So if you need some real-time kind of, if you have a real-time need, then you probably want to use the listener-based approach. And as you can see, the main difference here is I have get documents for the single fetch approach, and for listener, I would use add snapshot listener. And one more thing to keep in mind is that I've been using the key value, the dictionary-based approach to deal with my document data, but you could also convert it to a quotable model. So just wanted to mention that. Now, I talked about indexing, so you probably are curious, or maybe some of you would like to know more about what indexing is. Some of you already know, but I'll just explain it like this. You know how at the end of any academic book or reference book, you have an index so that you can easily find content? So let's consider the book Sapiens. Now you know that this can be a really heavy read, and you might find yourself looking at the index to search for something. Let's say I want to learn more about famine. Now, because the index is placed alphabetically, and I know my alphabet, I can easily scroll through it and find the word famine. And right beside that, I can see that there are these different page numbers, and I can now go to any of these pages to learn more about it. So this saves me from the trouble of having to scan through the entire book and search through it. So Firestore does a very similar thing for indexing. It creates a single index for all your fields automatically. So this is great because this really helps with retrieving your data when you execute those queries. So let's just look at the behind the scenes to get a little idea of how it works. So like I said, these single indexes are automatically created. So when I run a query like this, when I said activity type is equal to conference, so there is already an index created for me for this field called activity type, and it would look something like this. So the index is created when the document is created, so this is done for you beforehand. Now, what Firestore will do is it will look at this index, and since it is already sorted, it's very easy to search through it. And it will look for the word conference, and once it does find that word, it can now find the location of the document that has this term conference. So that makes it very easy to retrieve the document. Also, what Firestore will do is it will look at the adjacent rows in this index so that if it finds more documents that match your request, it can pick up those documents as well. But right after the word conference is the word course, which is not a match, so Firestore will stop searching. So even this query is supported by a single index. It would again look at the rating and then find the matches for you. You can even combine equality operators. So if I want to find out how many of my conferences were organized by 360 Dev, so I can look at the activity type index and the organizer index. And what Firestore will do is it will kind of intersect these two indexes. It has its own algorithm to do that and find a match. So that's how Firestore would execute, equality operators. And all this indexing is great because Firestore does not have to look through the entire database. And also, the size of your database would not affect query performance. So if you have just one document, or you have a handful or a lot of documents, it wouldn't really matter, because if you run a query like this, what Firestore will do is it will look at its index, find the matches, go to those locations, and then send those documents back to you. So retrieval is really fast with Firestore because of all this indexing. However, if you want to run a query where you, let's say, want to find out activity type is equal to conference, but you also want to add rating is greater than 7. So the challenge is that you're using an equality operator as well as a range operator, and Firestore cannot use its intersecting algorithm that I talked about, because it is difficult for it to intersect these kind of situations. So for that, what you can do is you can help Firestore by creating a composite index. So to create this composite index, all you need to do is, the easiest way to do is, you just execute this query on Xcode. Xcode is going to scream at you, but it's also going to give you a URL so that you can just copy paste that, and it will generate the composite index for you. So you're done. So a composite index is basically a concatenation of these indexes. But keep in mind that there is a limit to composite indexes, and that is 200. Now, how many of you have been tweeting about 360 IDEV? I'm sure a lot of us, right? Because we like to be on Twitter and talk about all these things that we are engaged in. So how about we store this write-up information so that we can keep track of all these write-ups that we have on different social media platforms or even our own notes, right? So how would I store this write-up? One way is I can store it as one long string. That's one way to go about it. But if I have some associated fields, like I want to track things like the date of that write-up and the platform, things like that, I could store it as a map. Map is basically a nested JSON. And this is definitely one way to go about it. And let's say I have multiple write-ups. I could then, store it as an array of these write-ups. And this is great, but you might want to consider how your app looks, because the way you design your app would really influence your Firestore database. So typically an app like this would look like a table view or a list view, where you have some basic information for your different activities, like the name of the event, the type of this activity, as well as maybe rating, right? I would just put few fields and don't want to overwhelm my user. And it's only that when the user clicks on one of these rows, that's when you would probably show them more details, right? So consider this situation where I'm downloading more information than I need, because you can retrieve documents as a whole, you cannot retrieve them partially. So if I want to avoid downloading more information than I need, then I probably want to place these write-ups in a sub-collection. So this is just like any app which has more retrieval, more reading than actually looking into the details. Like, for instance, if you look at the IMDb app or the OpenTable app, users are typically scrolling and not always looking at the details for every single thing, like in here. So let's look at what the sub-collection-based approach would be. So I could have my activity document with all its data, and this activity document can point to a sub-collection of various write-ups. So now I can have a short and sweet tweet. I could have a more professional LinkedIn version of this activity, and perhaps I'm also on Instagram, right? So I can now maintain a sub-collection of these write-ups. So the database so far would look like this. I would have my activities collection of various activity documents. So maybe I also attended an Android meetup because I wanted to learn more about the other side. And these activities could have references to their own sub-collection of write-ups, like we discussed. It's not necessary because, again, Firestore is flexible that way. I could have a write-up sub-collection for Android. So this is what my DB looks like so far. Now let's say I want to find out how many of my activities did I tweet about. Can you see that there is a little challenge here, because the activity write-ups are now in different sub-collections. And I'm trying to get Firestore to pretend as though all these collections are one big collection. The good news is that Firestore does allow that, but you would need to create a collection group query for this, and then you can totally run that query and get your tweet activity documents. But keep in mind that when you create this collection group, you need to, again, use a composite index so that Firestore can then combine the indexes for all these collections. So this is great. And let's look at one more thing. So what are conferences great for? Conferences are great for learning and networking, and also I think the eating part is great, right? But on a more serious note, if you want to keep track of the folks you met at these different activities and conferences, we could maybe add our connections field. So how would I store these connections? I could probably store them as a sub-collection, just like I did for write-ups. That is one way to go about it. But I could also probably place my connections at the base collection with the activities collection. So I'll just show you what that looks like. So I have my activities collection, and each of these documents could have their own write-up sub-collections. But now I can place my connections at the top level. So this is another way to design your database. And it would, if you're wondering which one should I use, the sub-collection based approach or the top level based approach, the answer is, of course, it depends. It depends on what kind of queries you plan to run. If your queries are independent of their parent document, then this is a great approach. But if you plan to find out information about your connections based on the activity that you met them in, if that is the majority of your queries, then you probably want to use the sub-collection based approach. And while we are here, why not track every single conversation that you've had with every single connection and just go crazy with this? So yeah. So yeah, these are the that was Firestore, but of course Firestore has its limitations. It does not support AppClip and watchOS. And queries also have their own limitations. You cannot do those join kind of queries that easily. And also, you cannot use range operators on different fields. So there are some limitations with queries that you might want to keep in mind. And also, Firestore, of course, has its imposed limitations, like there's only one write on a document per second, which is like a soft limit. But if you plan to have a very real-time kind of an application, then you might want to rethink that, depending on your needs. And then there are other limitations like the 1 MB document size, which should generally suffice because you just have simple fields like strings and numbers and stuff. And also there are 200 composite indexes, as we talked about. So in a nutshell, Firestore has support for creating documents within a collection as well as within collection groups. And you can execute your queries as a single fetch or a real-time listener. And you know that Firestore automatically indexes the fields for all your documents, all the fields of your documents, which can really help with fast retrieval. But for situations when it cannot, you might want to use composite indexes. And of course, there are various approaches, like using a map or a sub-collection or top level. You'll have to make those trade-offs. But there is so much more. This is an introductory talk, so there are more concepts that you'd be interested in knowing, and that is queries can also support sorting. So you can sort things in ascending or descending manners. And also, they have some, you can also do limits on queries, as well as pagination, because you don't want this endless scrolling kind of a thing. And also it has a great offline support, and transactions and batch writes are supported by Firestore. So this was a lot of information, so I'll wrap up. I hope you're convinced that Firestore is like having my cake and eating it too, because you can leverage Google Cloud, and it has a robust client library. It is pretty easy to set up. Plus, you have security rules, and it's great because it's flexible and it can support an iterative approach. And I'm sure many of us like to be, agile, so this is great. Plus, it supports, caching and transactions and pagination and all of that. So these are my references, and I primarily learned Firestore through the Google information, through their YouTube videos and their documentation on Firestore. But of course, there were many other references, and I wish I indexed them because that would have helped me review the content. And yeah, that's all. So thank you so much, and reach out to me if you'd like to on any of these social platforms. Thank you. So yeah, any questions? I'm checking out Slack as well.
Yeah, there's definitely time for questions.
Yeah. Go ahead. Yeah, one write on one particular document in a second. Yeah. So, I mean, you could write to other documents at the same time, but if you're working on the same document, then it's like a soft limit. You can still continue writing. It will just, take some more time. It may not perform it in that very second. Sorry? So it depends on what kind of applications you have. So if you have something which is very real time, maybe something which is like a chat application, you might not be able to use this. You can, but it depends. But if like a lot of people are chatting at the same time, then that might be, writing to the same document, and that could be a lot. But for something like where you're doing very few write-ups for the same document, then it should not be that much of a concern. And yeah, anything else? You can always reach out to me even after. I think you have a question? Yeah. Yeah, so pricing I agree, it can be a concern based on what I've at least read, and I also talk about this. So okay, so you were talking about how pricing could, yeah, when it's very big, when the database is really big. So yeah, Firestore can get expensive based on all these blogs that I've read. So it depends on the size of your data. And how pricing works in Firestore is that it primarily depends on the read and write operations. And also there are other things like your indexes and your metadata. So one best practice that you should really consider is the indexing part, because if you don't really need the index for some fields, then you might as well just create an exception for those indexes so that you're not wasting all that storage. So some of these kind of best practices on how you structure your Firestore really makes a big difference. And there's also a pricing calculator that can help you plan. I put the link in there, and you can also have some quotas and things like that so that you can figure it out. But following best practices can make a big difference. Anything else? You can always reach out to me otherwise. All right, thank you so much.